Good afternoon, friends. I am Dr. R. Muham, working as assistant professor in the Department of Mathematics, Periyar Maniyamma Institute of Science and Technology, Vallam, Tanjavur, Tamil Nadu, India. Actually, my paper title is Markov Chain Model for Environmental Issues at the Pre-Pandemic COVID-19 period. Actually, the conference title is Two-Day International Web Conference on Creation and Well-Being in the New Changing World. I would like to thank the organizing team, Devan Institute of Management Studies, Department of Education, Meerut, Uttar Pradesh, India. So in my paper, we are focusing the abstract. In the modern world, environmental issues is a very big task for the human being, especially air pollution. Measuring the air pollution based on the air quality index, we used Markov chain model. The Markov chain is generally used in many areas like manpower model, human resource management, inventory management, and in several other fields based on its efficiency. Markov chain model had been applying for prediction of the air pollution based on the air quality index. So in this paper, we are focusing the prediction and the measurements of air pollution based on the air quality index using the transition probability matrix. The result will give the forecast value with a high accuracy. So these are my keywords. And the many researchers are doing the research in this familiar field due to time constraint. Now we will move on the main concept. So that is methods and materials. So in this area, we are representing the data collection. So the data was collected from the website for this study. In this study, we are taken data from May 2015 to December 2019. In the study area of Manali, Chennai, based on the air pollution, a real-time air quality index. So this is air pollution location map. The second figure shows that the AQ index Manali area, Chennai, Tamil Nadu. The figure 3 represents the PM 2.5 AQ data from January 2019 to December 2020. Fourth figure representing the AQ data from January 2017 to December 2018. Figure 5 representing that the AQ data from May 2015 to December 2016. Similarly, here we have 5 years data. It was collected from May 2015 to December 2019. In Chennai, there are 5 monitoring stations that can express the changes of the air quality. In this case study, we are focusing the Manali area in Chennai city. Based on this data, we are concentrating the average air pollution, PM 2.5, PM 10, O3, NO2, SO2, and CO value can be expressed based on the pollution of dominant. So the next main area is analysis. So in this analysis, the first table representing the frequency of API state categories in Manali, particularly in the Chennai city, Tamil Nadu. Here we have 5 states, 1 to 5, and the corresponding status of API were given, like good, moderate, unhealthy, very unhealthy, and hazardous, and the corresponding frequencies are given. So similarly here, the table 2 represents the air quality index scale and health implications. Here we have the ranges from 0 to 50. It is good. Similarly here 51 to 100 up to the 300 plus. And the corresponding air pollution level, it will be moderate, unhealthy of sensitive groups up to hazardous. And the corresponding transition matrix were given. So then based on this data, we are formulating the Markov model based on the Markov chain. It is represented in the equation number 1, 2, 3. Based on this, here we can find the transition probability matrix. It is represented in the equation number 4. Based on this, here we can find the cumulative transition probability matrix. It is also represented in the equation number 5. Based on the equation number 5, we can find the steady state of probability of Markov chain for the various 5 states. It is also represented in the equation number 6. So with this, here we can represent the Markov chain model of air quality and air pollution in the equation number 6. So based on this, here we can find the simulation model for this Markov chain. We are calculating the air pollution based on the state 1, 2, 3 up to n. So here we have only 5 states. So here we can use state I, 2, 1. So in general, here the random numbers means it is lies between 0 to 1. So the next table 4 represents the air quality index, and the Monte Carlo simulations are also given for the 5 states. Next, table 5 representing the Monte Carlo simulation of air quality index. Here the year-wise random numbers and the corresponding dates are given. For this, we can find the main variance, standard deviation, skewness, and kurtosis based on the descriptive statistics value using the spaces software. The values are given. Next, the figure 6 represents the annual variations of average AP index. So with this, my conclusion is, this study results explained that the Markov chain model how fit the air pollution data from May 2015 to December 2019. This Markov model is more reliable to other model. This case study of the air pollution in the area of Manali, Chennai city, particularly in Tamil Nadu, from May 2015 to December 2019, which has 5 states in the finite level to predict the future level of the AP. Based on the transition probability matrix, it is explained that if the air pollution level is in the previous year was good, in the state 0.992528, in the state second state that is here in the moderate level, the value lies between 0.9665 and 0.7584. Similarly, we can represent the third, fourth, fifth, and fifth state like unhealthy, very unhealthy, and hazardous level of API. Finally, the Markov chain model gives the exact value of the air quality, and its performance is more appropriate for the forecasting of API index. So, and also I would like to give my suggestion for this paper. So it is suggested that there is a relationship between higher concentrations of air pollution and higher risks of COVID-19 infection. It is also suggested that the state and central government can take more initiative to reduce the air quality during this lockdown period. It will take India's growth to high position in all the directions. So these are my references. Thank you. Thank you, Anandal. Thank you. Thank you for your patience.